Rasulillah. For the current members of the Muslim group, as well as old members, we always talk about this, how the purpose of this group is wholesome improvement, right? Comprehensive on all different facets. You know, when it comes to our deen, when it comes to knowledge of our deen, when it comes to business skills, social skills, career, everything. We want to grow as men in a complete fashion. So one of the things that we've been doing in the past, we did business workshops, got different folks come in and talk to us about different careers and so on. So in the spirit of that, we have come up with the idea that, you know, brother Khalid Mashal here, we work together at G Appliances. He's maybe 7 desks away from me. And so we were talking, I think a couple weeks ago, randomly about something, and he has a passion for giving back to the community and teaching and mentoring, and I have a passion for trying to get connects to our community. So as we were talking, I was like, wait a minute, I have the perfect trial group for you. I have our men's group, Muhsineen, if you could come and do a workshop on artificial intelligence, AI, right? AI is everywhere, we always hear about it. We put in the survey, obviously this is subjective. Someone might consider themselves average, but we don't really know what that is. So I'll leave it to Khalid here to kind of parse through that data and figure out where everyone's level is. So inshallah, my hope is this is a first, but not a last for sure. And you know, depending on people's needs and their understanding, we can have future workshops, inshallah. So Khalid Mashal here, you know, he's got a background in electrical engineering. He's, you know, Palestinian by blood, if you will, right? Chicago native, and then he came here, but at this point, you're Lavillian native. I mean, 17, 18 years now? 15, so 15 years in Louisville, whole time working at G Appliances, so very knowledgeable when it comes to this. In the building that I work in, right? Oh, actually, all the most of the company, like when you hear AI, they're like, oh, Khalid is doing something, let's go talk to him. So just a little bit about him. Inshallah, he can come and further introduce himself and kind of get us started. Jazakallah khair for taking the time.
Is my voice reached? Can you hear me? Good. So, Assalamu alaikum. Salatu wassalamu ala Rasulillah. First, I prepared a really small intro just so we ground each other where I'm at. I mean, I try to make it a little bit more personal. You know, I'm a principal advanced system engineer. Basically, that's the equivalence when you talk universities R&D research. So each business has their own research, and my job is to think 5-year forwards of customers' needs and experience, and try to make features and look at cutting edge technology, see where the status of the technology, the needs of the customers, and marry both together in creating you know, and meeting these needs, and hopefully getting our company, you know, to compete better with everybody else in the market by offering new cutting edge technologies that not necessarily impressive. We're in a business of selling products, so we want to make sure people have a need for those services. So my job is basically to focus on, specifically I'm focused on AI and AR. So AR is a whole different thing we can talk about later, but augmented reality, I'm sure you guys heard about it because Apple came out with something, right? But today we're talking about AI because that's the title of that. So you know, just a little bit of my interests. I love traveling. I'm a scuba diver. I mean, I had logged over 100 dives, so I love diving. So that's a side thing. Another thing, I'm a Palestinian from Jerusalem, so born in Jerusalem, raised in Palestine, came after high school, actually after the first year in universities, after Intifada started. I moved to the state and then continue my education in Chicago. So I'm a graduate of the University of Illinois, Urbana-Champaign. So I call Chicago as my home. I mean, Louisville is my second home. But that's where family is, most of my family. So thank God they've been safe so far, alhamdulillah, with all the things happening. So that's just a little bit about me in a nutshell. I guess since I work in R&D, I guess something to, I have over 30 patents filed, and mostly around artificial intelligence. So there's other things I've been working on in R&D group. But most of what we work on is basically future technologies that hopefully add values to our customers in their homes, because we make appliances, right? So What I wanted to, as I was thinking and reading all your questions, thanks for submitting all these questions because I'm going to use those as my compass to kind of cover things, and then we see how we do, and then we can kind of like come back and we'll open it up for questions and answers and kind of have a dialogue discussions with you guys and kind of like see where we at and see what we want to answer, what we want to cover in the future, things like that. But I wanted to touch on this, and this is usually my leading slide. I teach a lot of courses in the company too on AI, so this is one of my leading slides. It's like, why should we care? Why is AI? I mean, I know ChatGPT is out there and everybody's talking about it, but that's not really what we're in for here. There's a lot. This is a research by, I think it's kind of blurry, but it's a Harvard Business School of Business here. They did a research on, basically they partner with one of those Boston consulting groups. I guess it's pretty famous consulting groups that you guys probably heard about. And this professor,
What's the name of it?
Boston
BCG.
Consulting Group, Engineering Consulting Group, yeah. So essentially, they did a study on productivity of engineers, because that's where you hear businesses is more interested in it, because basically what this research shows, basically what they did, they had 3 different groups. So they broke them into 2 different groups. First group, they just gave them tasks, the same task. Everybody got the same tasks to accomplish for business. So one group, they gave them nothing. They said, here's the task, go get them done. Second group was given ChatGPT access or whatever. And then they say, go do this without education, without telling them what to do, nothing. You just, here's the task, here's the access, go do it. And then the third group actually were given a little bit of prompt engineering. I've seen some question around that, or how you talk to this AI tool in the most effective way and get the most out of it. A little bit of an intro to it, kind of like just here's how you can effectively use these tools. And what the research shows is there's a great shift, and I know probably there's some mathematic guys, but essentially there's a great improvements that shows with people that actually had the education and the same task. They seen a very noticeable productivity increase and very noticeable quality increase in their work. So this is what kind of this is one of the early studies. I'm sure there's a lot more studies right now, but essentially the bottom line is now why businesses is kind of running after this is showing it can add a lot of productivity, and in business minds this means more money with less people, right? So essentially it makes sense. People is kind of like do the best to kind of make sure they enable that in their business. But the question how they do that, that's a whole different discussion. We'll talk about that a little bit. But also this is another one by another study by Goldman Sachs. Essentially they're showing you how much money potentially can be made in that field. And that's why I'm excited to I'm passionate about, especially about our Muslim brothers and sisters, to kind of get their minds in the game, because there's a lot of wealth to be created. We're kind of like, if you guys, I don't know, probably not, but if you read about the software, a whole industry of software and how it got started and everything else, it was no tools. It was just a new thing, and look at how much created for the market. But the prediction is that AI is even going to be bigger than that. So essentially people that can wrap their head around the technology, start thinking about it, how to use it in the best way, it's only going to get better, and it's only going to create more opportunities for people to actually grow and become the next entrepreneurs, the next Googles, the next Meta, whatever, of the future, essentially. So you'll see a lot of that happening. There's a lot of startups in that space. One of our brothers, part of one of them, very intimately familiar with it. And so there's a lot of that happening, and there's a lot of money and investments and people supporting it. So it's just a matter of getting in the fields, understanding that, and understanding the needs. And I'll tell you, I'm a big believer of the next innovation is going to come not from the next ChatGPT or the next models or the next whatever. That's going to always get better. It's going to get like the internet. It's going to get better with time. But really, what's going to the future is going to be the future of entrepreneurships and value creation is going to come from experts in their fields, taking interest in these things, essentially wanting to change the way they do X, Y, Z, whatever that is. And they're the experts, so they'll know in their field there is a need there, this and that, and then they'll be taking an interest of that, they'll be, that's where the next innovation up. And I'll give more examples to ground that up a little bit later on. But I wanted to kind of, I know, sorry for some people that know the actual basics, but I wanted to kind of, I didn't know because I've seen the survey, everybody's everywhere, right? So I wanted to kind of get everybody on the same page, so I apologize for people that know the basics, but I wanted to kind of start there anyway, and kind of get that so everybody's on the same page, and then we'll move from there and get a little bit more advanced as much as time allows. So essentially, AI is not a new thing. As a matter of fact, it's been around since the 50s. There's many, if you will, winters, they call them, of AIs, right? So they got, you know, it was the best thing that people talked about, then they had a problem, and then it died off, and then it came back, and it died off. But really, we're in this block right here, which is called the deep learning. And if I wanna kind of progress in definitions, artificial intelligence is anything that try to mimic human behaviors. So if I take any readings and I try to reason with it, and even software, right? If I read this sensor that does this, then do that, the if statement thing, that's an intelligence. That's a form of intelligence. So that's why it's loosely defined. So you see it on all the products. People say, we got AI, we got AI, we got AI everywhere. It's confusing everybody what is the real AI is. Because technically you can claim AI by anything that try to mimic people behaviors or a human being way of thinking about things or rationalizing about something, right? So that's why a lot of people slap AI on their products, and you see, oh, this thing got AI, this thing got AI. You know, that's what's going on, you know? And so that's the bigger circle of called artificial intelligence. It's a dream been coming through. Essentially, people always dreamt about machines. You see in a lot of movies, right? Of machines trying to be behaving like a human or thinking like a human or rationalizing about something like it. So that's the whole thing. Since the 50s, you see it, you can go as back as the 50s and before even, and find all kind of things, people thinking and fantasizing about these machines that's going to be smart or take over the world, right? You hear that all the time. Essentially,
But
from
is it right?
No. Nobody's going to take over the world soon. That's for sure. We're still far from that. Way far.
But they're already taking jobs.
Yes, we got to get to that. I'm a big opponent of saying AI is never going to take your job, but people with the knowledge of AI, and we're starting here, will take your job. Okay? That's for sure. I promise you. So we're starting with the knowledge. So with knowledge is power, right? So if we're educated, we know what's these tools, what they do. That's the first step. Then you will find out what to do in your job. Then you become competitive. Then you can keep your job. Because everybody's gonna, I mean, it's one of those things. Can you imagine when electricity, and I know he works with the professors, Andrew Ng always says it's the next electricity. You know, do you remember when did you read about the history of electricity when it started? And how people kind of like, a lot of people probably thought in the beginning, this thing is gonna kill us all, right? It shocks people, it just only harms people, right? What the hell is this thing gonna do to me good? Can you imagine if people, those guys stuck with, I wanna do manual work all my life and I'm not gonna get on an electricity thing because it's so dangerous? You know, they're probably part of history right now. They can't even compete with anything. Like imagine doing construction using the pyramid style building equipments, you know what I'm saying? So this is what's happening right now. So we're early on in the AI where if you wanna go against it, you're only gonna lose, because you just have to embrace it and understand where you can use it, because it's gonna better you if you use it the right way. And we'll talk about the right way and the good ways later. And obviously there's limitation and other things that we can talk about. It's not a solution for everything. It doesn't mean you got to take your head out of the game. You always got to stay in the game and understand what you're doing and how you're doing it. There are certain ways and certain tools and certain use cases that will be productive for those tools. So we'll talk about that a little bit. Now, machine learning is within AI. This is when basically the introduction of statistics and other tools were introduced to rationalize with artificial intelligence. So this is what we call the classical AIs. It's part of data science. That's when data science kind of got created. You know, that's when you hear, you know, this is when basically they're basically looking at using mathematics and statistics in within the field, rationalizing about like data and learning data. Basically, the idea here with this field is essentially you start with data and you try to understand the pattern in that data, and you try to write some kind of mathematical function or that will represent that data, and hopefully you can use that function to actually make sense of new data that comes through. So imagine you're just trying to represent the data. This is what they do in banking, like when you apply for a loan or whatever, they try to see how do you qualify or not, right? It goes through some kind of algorithms that was trained on a historical data of a lot of people that applied and qualified and actually came through and paid off their loans. They learn from that data, and then they'll decide based on your inputs if you're a good candidate or not. Things like that, right? That's the data science. That's where data science got created. Things like that. You hear there's a bunch of different tools there. Now, we couldn't cross to this field, which is called deep learning, because of the limitation of computations. Because computers were there, but they're not there in terms of powerful the way and even algorithms weren't even there to really, if you will, crunch a lot of data to learn from big data, if you will. And this is when deep learning really became a thing, and it's pretty recent, in the 2010-ish, start taking off. That's basically when everybody's online, essentially. We start going online, the internet is a thing, everybody's browsing, we got a massive amount of data on every single person, right? Because you know what they like, you know what they click on, all these things, right? So people were thinking, how can we take advantage and maybe use machine learning, because that was the only tool they had. And they found that thing failed when it comes to these huge amount of data and trying to like make sense of it and find a pattern about what you like. Like when you go on Amazon's, they show you here's what you might like, right? That's AI actually figuring out that based on all the historical data they got on you and all the purchases that you made and things like that, right? So this is when computers became, and this is when NVIDIA and these other guys start taking off, essentially. Is basically we start figuring out how we can run these computations in parallel on GPUs, which used to be used for gaming. NVIDIA was in the gaming, that's why they became leaders. Now they were just positioned right and kind of invested in that field. So now we start looking at algorithms that can run things computation in parallel, very effective, and also we have a lot of data. So computing came in, data is there. And then also algorithms is up to date and start working with these together. So those are the three ingredients that really launched this deep learning revolutions that we hear about. And you're gonna ask me, where's Gen AI? So Gen AI is right here. It's a sub-portion of deep learning. It's just generative AI, I would say, it's basically, we'll talk about it a little deeper. I have more slides on that because I know that's the interest from all the questions I see here, obviously. So the idea here, 2017, a paper was released by Google, Attention All You Need. It's a new algorithm called transformer architecture. And essentially that idea, we always had ways to, if you will, rationalize about language and use language into algorithms before generative AI showed on the scenes in these algorithms. But particularly in 2017, we had this new algorithms that made it possible and sustainable to ingest a lot more data in parallel. And I'm trying to simplify things as much as I can, and really learn the pattern more effectively on a same computational limited resources. So you can do more with less, essentially, in that algorithm. And that's what launched the whole generative AI. So now people say, okay, now I can ingest a lot of data and learn from it, especially language data, text and everything else. And we'll talk about how this works a little bit more. But they created, actually Google came up with it, and it's kind of funny, and then OpenAI did take it and kind of work on it and develop it more, and they came back with make the story, long story short, they came out with the ChatGPT that you guys know, with just building on top of that architecture, and now they're lagging behind OpenAI. So it's kind of one of those funny story you start, and the beauty of AI, there's a lot of open source, meaning a lot of that cutting edge research is put out for everybody. It's just a matter of what you want to pick up and what interests you want to have, and how can you build with that and kind of build on top of it and get it. So they picked up that paper, they picked up the idea, they developed it, they advanced it, they came out with the GPT models and all these other things. Obviously they added to it, they modified it, it's a research company. OpenAI used to be a non-profit organization. Actually, they were just interested in what we call general AI, which is what you're afraid of, is having machines that really like a human being. But they're on the path, but no, not even close. So you shouldn't be fearing anything yet of that yet. But essentially, I wanted to also ground us of what is the traditional programming versus machine learning. What does that mean? So traditional programming, you have data and you write a program to rationalize about data. If this temperature sensor read 70 degrees, I'm doing this and this and that. Just like the air condition controls here. It reads, I set it to 70 degrees. If it goes above 70, I'm turning on the air condition, right? So that's a program. And then that's the output. I turn on the condition, right? But when it comes to machine learning, it flips it on its head. Essentially, I want to start with data, and I want to start with the output, meaning I have these sensors data, but I know the machine did X, Y, Z. For example, I don't know, if I want to develop an algorithms to detect when water boiling or whatever. So I would be collecting temperature data, and obviously you guys know when we go different pressures, you don't know when it's going to boil based on the pressure. So really it's not a constant thing. Depending on the location, you might have different things. So essentially you can take data, you can say boil or not, and then you take that data and you train a model, and then it come out with an algorithms that we talked about. That algorithms basically, hopefully if you did a good job, if you give it a new temperature or new reading sensors, maybe you have your GPS location and maybe your temperature sensor. Those are two sensors you're looking at. You feed them in and it will be able to tell you this thing boiling or not right away. It learns from data, it looks for patterns in data, and it gives you an answer, versus you have data, you write a program, you make the program, it's not learning from anything, and then you have it. So it's a different way of thinking, if you will, about data, and that's key different between traditional ways of doing programming versus the new ways. There's many types of machine learning. I just wanted, I guess you can kind of like look at the type of data. That's temperature is a time series data, for example, or images or voice or sounds, but that's not really how they classify it in the fields. You can also talk where you can also talk about where the thing is living. Is it living on the device versus in the cloud? But really the official way of really talking about types is not that. These are the, if you will, if you've opened any OpenAI, if you open any AI book, if you will, these are the 4 types. Some people add or subtract or whatever, but these are the main 4 types they talk about. So there's something called supervised, unsupervised, semi-supervised, and reinforcement. And I'm going to dive deep a little bit quickly on all of these, what I mean. So supervised learning, meaning I got data with labels, meaning in this case I got circles, I got circles, triangles, and hexagons, right? These are my labels, I call them, and these are the data, if you will. I feed them into my machine, and then I would train my model, and then hopefully it will be able to predict when I feed new data. And I'm not saying shapes here, we could be shape if we're doing images, but essentially you feed data, you feed what they are, labels with those, and the model will learn to predict that data based on the label. And when all said and done, I'll take my model and feed it data that never seen before, and I'm looking for that model to give me a label, essentially, what that data is. So that's called supervised learning. By the way, this is one of the biggest, go ahead.
Yeah, so you're saying someone is feeding into the machine that you see this here, this is a circle, this is a rectangle, this is this, so that's the supervised.
Correct.
You're feeding the shapes,
Right.
but you're also telling the machine,
Exactly.
this is a circle, this is this.
100%.
You train the machine, and then when you have that model,
Right.
then you don't tell it what it is, but you throw a thing at it to test it.
Correct.
What is this?
Correct.
And it'll use based off of the data that you labeled before,
100%.
and it'll say, oh, this must be a triangle.
Exactly.
So that's what this is.
Exactly. 100%. It's kind of like teaching your kid, like little kids, here, whenever they see a dog first time, this is a dog. And then when they see a dog next time, even if it looks different, a whole breed of dog, different, they'll be able to recognize, oh, this is a dog. You know what I'm saying? And the same thing goes with these models. So I would say this is the most common, if you will, machine learning algorithms that you see there. I mean, this is where I would say 60 to 70% of all the different so-called AI applications live. I mean, it's kind of shifting with new algorithms kind of happening, but we'll talk about. But this is by far the most common way of doing AI. So if I'm looking to teach an app how to recognize different types of plants or plant diseases, let's give a good example. So I take a bunch of images of all the different diseases. I will circle this and I will name it. This is called labeling the data. And then from there, I'll feed it to the model, let it kind of go in circles and train and minimize the error. And I use so-called this test data to judge how I'm doing. Basically, I take portion of my data, hide it away, and I start training, and somewhere in the middle, I'll inject some of that unknown data and say, what do you do? And then I'll have a grading, how did it do on that? And then if it's not doing good, I keep going in circle until I kind of improve my accuracy over time. And then when I'm set and done, I'll graduate that model to be in an app where you can just snap a picture and it tells you what it is. So if I did a good job, it should do good on data that I never seen. So unsupervised learning, essentially this is where I feed it unlabeled data. And when I say these types, and we're kind of simplifying it, but under each of these, if you will, topics, there's set algorithms and ways that works in these fields. It's not everything can do everything. It's just there's set amount of algorithms that can do supervised and unsupervised and other things. So unsupervised learning, so you can, a good example of that is clustering. So if I feed a bunch of different data and I just say, tell me what's similar, group the similar things together. I don't care what they are. They might not know they're circles and hexagon or whatever, but they'll do something and they'll say, oh, these things look like alike. So we're just clustering them. And then I'll come back later and say, interesting, this is my, failure on XYZ, whatever, or this is what happens when somebody hacks my system, whatever. I mean, it could be any kind of data, and we're talking about, and these are pretty common when you don't know what you're looking for. You just want to see what's the patterns out there, what's the and you try to group things by. It's good.
So how do you tell it that this result is right? Keep doing this.
I don't. All I do is I give it data and I say, find some patterns and find some similarities between things. And
But what if it just does not go that route? How do you make sure that, hey, this is the type of patterns that I'm looking for?
the algorithms that they use in this field is designed to do
Okay.
so.
Gotcha.
So they'll use all kind of variables to make sure they're kind of doing their job in the way we kind of. So they're designed for that task, if you will. So there's many different ones of ways of doing it. But essentially, they don't know what they put together. They just know this is a similar group, and they're not perfect. I'm showing them perfect, but they might have a triangle here that they were confused about or whatever. But that gives me an idea or a general idea where things is, and I can kind of come back and kind of a little bit hell bit later and label some of that, and I'll say you this is where it comes down to this next. I guess I skipped one. This is what comes back to this semi-supervised. So I'll give it unknown data, I'll let it cluster it, then I'll go label those clusters because I agree that yes, these are circle, these are whatever, these are triangles, and then I'll take that little data and train a model. Remember the supervised one? So I use those labels that I just created by clustering, and I help it by looking at, oh yeah, all this data, I'm gonna call it, circle, even though it's not perfect. And these are triangle, these whatever. And then I'll take these bunch of data and I'll train a supervised model on it. And that's why they call it semi-supervised. So because I started with unlabeled data, and the way here is just to save time on labeling data because it's a pretty intense job to label a lot of data to really get algorithms to do good, especially if you're training from zero. obviously you can use transfer learning and other things, meaning algorithms that actually been trained on similar data. You just give it a little bit more of what you care about and you let it do a better job on that. So other one is pretty interesting, reinforcement learning. And this is, I think, let's talk about, for the gamers, this is the best one here. Essentially, imagine you're in a game, you're a character, and you're acting on this environments. Environments meaning like whatever that game, you're trying to get something, you're trying to score points, right? So there's ways you can count your points, right? That's called rewards. So essentially, you act on the environment, something happens, you either lose or win, but you tally up the score, and then you know what kind of move you did. So this agent, what we call is basically your character in the easiest way to think about it in that game, playing the game on its own, and trying different things and then dying off or doing something, and it kind of iterates. So you see that this is how they do a lot of these agents that play really well. I don't know if they're probably online in a lot of games where you can't win against them, right?
Yeah.
These are probably trained
like chess.
Yes.
Yeah.
So, but my favorite movie in this field is this, AlphaGo from Google.
yeah.
So you probably want to watch that, right? It's one of those, essentially one of the first people to kind of use this technology is on, I don't know if you guys are familiar with AlphaGo, but it's a lot harder than chess. But there's that Korean war champion that they had the computer play him, and he lost to that because that algorithm were trained in this fashion. So they let that algorithm learn watch a lot of video of AlphaGo on its own and learn all the moves, and then also let it play itself for a long time until it was better than the war champion, and it beat the war champion once or twice or three times. I think he only won once against that. I can't remember. But this is a worth watching movie. It's called AlphaGo. It kind of gives you a little bit of insights of what this is. But the idea is if you let it play on its own, it will get better than a human being and actually playing that game or doing a task. It could be a task, but you see it a lot in gaming because it's a safer environment. You don't want robots doing things and learning in an environments like this, right? So you see it a lot in gaming, but it's getting there because they're finding ways to kind of make it safer and test it and do things like that. But yeah, it's just that's an interesting field that are up and coming, and you'll see it used in ChatGPT. I'll show you a little bit. We'll dive a little deeper. This is from Gartner's. It's just a little deeper of the different components of what generative AI is. We talked about generative AI. Generative AI is anything that can generate something. That's where the generative comes from. Like if it's generating a text, if it's generating an image, if it's generating a sound, that's what they call it, generative. But they all hinge on something called foundational model. And I want to ground you guys with these technologies because I want to a little bit demystify the actual ChatGPT and how it was created altogether. So this foundational model, essentially these are the models that you'll give it a lot of data and they would learn these data, and they have one goal in mind. It's basically, if I give you a sentence, once upon, and then I hide the next word, you'll know it's a once upon time, because most likely that's the next possible word, because that's what statistically, most people say it that way, right? So this is the foundational model. They'll be trained on tons and tons of data, and this is, I know somebody asked about training model. This is where a lot of money spent, essentially, because you'll feed it the whole internet, the whole books that humanity created, and you play a game with it of hiding different words or sentences or part of sentences or whatever, and you let it predict what was missing, and it just iterates for a month at a time on all that data using so much GPU. And we'll talk about how to give you an idea for somebody that asked about training model, what it takes to do that. And then from that, we get to something called large language model, and that's what the large comes from, because the large amount of data that was fit into it. And they all use the backbone of that transformer technology, obviously with a lot of modification, because research moved on from 2017, so there's a lot of better ways to do things within that technology. And then from there, we get the ChatGPT, and I'll show you a little bit deeper how that happens. So demystifying it. Essentially, like I said, we talked about this, how they get trains, you feed it the whole thing, and then it's just guessing the next word, right? That's what we just talked about. And I just want you to get your head wrapped around tokens, because that's the currency of these models. That's how they charge you for the cost of ChatGPT or whatever. So, I guess the tokens, you can think of it as a word, but really when computers doesn't understand language, so they need numbers. So what they did is they created this system called tokens. And tokens is nothing but, I guess I can take every word in English and make it a token, but that's not efficient, because there's ing repeats in a lot of sentences or a lot of words. So they broke the most repeated sequence of letters into tokens. So that's what they call tokens. So ing will get its own token, period, it gets its own token, and things like that. So roughly, if you want to do it, it's 0.75 of a word, if we want to calculate it. So it's not exactly a word, but that's the currency. When you talk to any of those chat models, they're counting your tokens in, tokens out, and that's how you're getting charged.
That's what they generate.
Yeah, well, they count them
Yeah.
every time. There's token in, and if you go on any of those cost websites, they have per million token, $15, for example, in ChatGPT, and per million token, and the output maybe is $20, because it's just comes, a lot. It takes a little bit more. So then they tally up that. So when you ask a question, they break it into tokens, and that comes with money. And then when it gets back to you, whatever number of words, they break it down on number of tokens, and they charge you per token, which it adds up as you use it intensely, essentially. But here's interesting. We talked about deleting, omitting languages and doing things. But here's what they noticed when they were building these models and training them. Initially, they had one goal in these. They were just wanting to train a model because they wanted to understand the English language like we do, because everybody was on a pursuit of making computers behave like us. Language was one of those things. So they wanted this model to really understand the structure of English language. And that's what they had initially, the researcher, when they were starting to train these models, so-called foundational models. But what was interesting, that these models not only if you will, understood the structure of English language, they retained all the knowledge in that data somehow in their memory. So, and you have in the foundation models, and if you have subscription to any of those or you play with it, there's sometimes they call it completion model. That's another way they call it. So if you try those models and you start a sentence, it just keeps going. Essentially, its goal is it would just once upon, and then it will do statistic. What's the most likely word? Say time, and then based on time, it will do statistic. What's the most likely next word? And it kind of keeps going until it hits a stop, or you have a limitation or some kind of thing. You say stop, but it kind of keeps going. What they did is they found out that the knowledge was retained in that thing. So that was a discovery as they're kind of training those models, and they. And that's where the chat. We'll see how the ChatGPT. So to tease that knowledge out of there, they were just giving it examples, question, answer. So they'll say, the capital of France is Paris. The capital of United States, and they say answer, and they leave it blank, and it completes it. So they knew that it's Washington D.C. So they figured out, okay, this knowledge is retained. Now, how can we make the model naturally helpful? And that's what a chat thing. So they fine-tuned the model later on with couplets of questions and answers to say, here is what I want you to behave like, and that's where the chat became. So before this, it's called GBT. Then the chat GBT is the one that is basically fine-tuned on questions and answers. I will dive a little deeper on that a little bit. Just some cool facts is the original chat GBT has 175, a lot more right now. Human beings have 86 billion neutrons, and we still do a lot better than these things. So, subhanAllah, we're still a lot capable than any of those guys. I mean, with less resources, we do more. So, here is GPT-3, and now it's an old news. Just to give you an idea the amount of data that was going into it. I did some math, rough math is about how many novel it takes, like converting that 3 billion tokens or 300 billion tokens that they used, roughly 2.5 million novels. I'm talking about 100K word novel. That was in GPT-3. Now we're talking about 4 and potentially 5 coming through. Way more, way more. So just-
so those different generations, do they build on top of what they had already
Yes.
trained? Okay. So
Yes.
it only becomes better than the previous
exactly. And they fix all the different issues that they found, and they also address all the things that they've seen from users and everything else. So it only gets better
Yeah.
and cheaper
Yeah.
because they're figuring out hacks that will make it not necessarily make it lose a lot of accuracy and still perform it really
More
well.
efficient.
Yeah. So let's see. This is a little bit so much going on here in this slide. I got the slides from Andrew Karpathy. He's one of the creators of OpenAI. This is his slides when he talked to the Microsoft team, if you will, about what the state of GPT is. And I find this very, very helpful to really understand, and I'll break it down. I know there's a lot there. Of how the chat GPT, and why I'm giving you guys this knowledge is because it helps to kind of know how this thing works for you to think about how you're going to use it. And you don't have to understand how to make one, and we'll talk about that. You can if you want to, but essentially it will give you an idea to start thinking, why did this thing didn't work or work best or whatever, right? So we talked about this first stage. This is what we call the foundational model. This is where you hear about bias, right? You hear about GPT giving you like bad data or bad information, because the original task was find as much text as you can find. I don't care where you find it, download the whole internet. We're just gonna find text because we need more text to get better, because those models seems to do better as we load them with more text. So guess what? When you download the whole internet, you can imagine how toxic that is, right? You can imagine how much bad things, bias, all kind of things that comes with that. And I think this is where OpenAI disagreed with another group that now they have their own models, Anthropic, that's the other guys. So they were ex-OpenAI guys that did not agree specifically with this because they want to spend a lot more time on the data to clean it up and kind of make sure it's not biased, it's not toxic. But it's a tall task. Imagine going through all the internet tasks and how much resources you would need to really do it. So that's where they kind of butt heads and kind of they open their own thing. And I'll come back to that, why I'm kind of bringing them up. Because they happen to be the second best models right now, even better than OpenAI right now, the recent model even. So this is where you hear about thing is biased, things is not correct, it's whatever on the internet there. That's the initial brain dump that they had on that model. So they did that. Then they this is for the brother that asked about, it takes about thousands of GPUs to train one of those models. And examples is GPT, Llama, and Palm, and all these things. And these take months at a time, and they output something what we call the base model or the foundational models or whatever. Now, this is the most expensive parts. This is what you hear millions and millions of dollars. That's why corporates like Google's and Meta and all these other people with deep pockets kind of like, that's what they give. But the beauty is there's a lot of open source. A lot of these guys, they open source those models. So it doesn't make sense if you're working on a new models that you start from scratch, because you can always start from here. But also you're inheriting those, right? Whatever, because that's a black box. We don't know what their data is. We don't know what their models think.
I still remember the first time I trained my model, and then I asked it was all Hitler and like like bad things, because
Yes.
Wikipedia is full of like everybody talks.
Yeah.
You gotta be careful.
You don't know what you don't know what you're getting. You just whatever, right? This is toxic here.
Yeah.
And they have guards, and somebody asked about guards. That's why they behave the same. But walking from this step, so they take this first model, if you will, after millions and millions of dollars and tons of data, God knows from where they get it, and then they would just move to the next step. And this is called supervised fine-tuning, and that's why we come back to the supervised. That's why I wanted to cover the supervised. So what they do is they task a team, and they create questions and answers specifically handcrafted by human beings to be helpful. Like what's the capital of France? It's Paris. Well, I'm simplifying, but you can go sophisticated, good quality, low quantity. This is high quantity, low quality data. This stage is about low quantity, high quality data. So essentially it's crafted questions and answers, and anywhere between 10,000 and 100,000 questions and answers that is really high quality. And what you do, you take that base model and you train it a little bit more, meaning you show it those questions and answers and you train it a little bit more. And that's what comes out of this process is what we call a supervised fine-tuned model. That model basically can, if we happens to create here question and answers, it understands the question answers if you give it a question answer. But you can do whatever you want here based on that fine-tuning to make that model go whatever way you want. From that stage, remember we talked about the reward model and how we do the game environments and acting that. So what they do is they take the supervised model, so-called chat models, and then this is really what this is the secret behind you feel like ChatGPT is a human like or whatever. So in this stage, what they do is essentially they let this thing. You take a ChatGPT model, fine-tuned model, and you ask it a bunch of different questions, and it's going to answer them different ways, like that ChatGPT answer in different ways. And then you would use a human to grade how likable that answer is. Meaning, like I can ask it, what's the definition of life, and it gets a bunch of different answers, and then you show people 3 different answers, and you let them rank their favorite to the least favorite. And from that, they model a function called the reward function. Essentially, that function, essentially think of it as tallying up the scores in your game, like how it works, that logic. This is tallying up the scores of how it's performing in relationship to a human being. Meaning, like, I am a human being, and you take a lot of people to look at it. It's not one guy, taking ChatGPT in their own way of life, right? But you can if you want to. That's when it comes to what. I don't know if they do it all. I don't know when there's some other political thing, but I wonder if that's what if you take it to these countries with oppressions, you probably do it the way the leader think or whatever. But you can do that essentially.
That's what I was about to ask. Like, what if the folks that would grade the results, what if they're biased from
yes.
them?
Yes.
That is what is happening.
And yes,
Yeah.
That is what is
humans
happening.
are biased.
Yeah.
That's given.
Yeah.
But hopefully when you design this stage, you got enough variations and you design it in a good statistical way where you cover a variety of people. But this is also the secret why ChatGPT took off a lot more, because a lot of people use this. So they have user data to begin with. That's why they got in trouble. So they know when you have thumbs up and thumbs down, that's doing this. So essentially you're telling it, I like this, I don't like that. And then they're using that data to come back and fine tune it. And hopefully if you get enough users behind it with different backgrounds, you get a good common models that behave like a human being that nobody can tell. So that's why most people think, oh, these things look like a human being. It really understand me, right? But that's really the secret, is because they align it with people's, if you will, preferred ways of answering things, or the information they like to read it in certain ways. And this becomes dangerous. So if I'm a dictator, I would want that model to be my way. I can do that too. So, but that's what happens in this model. That's when the model becomes a human-like. And then from there, that score, we let it chat with each other, and then we let it grade its answer, and then we fine-tune it to take those bad grades to the bottom of the list, and the good ones will go to the top, and then we end up with a model that always most likely is going to give you an answers that a human being like. And that's that last stage, reinforcement learning. That's why we covered it in the beginning. You let it chat with itself, and then you have a rewards. You tally up the rewards and say what's the most likely, and then you go back and modify the model. and then come back and ask it again and again and again like that until you get it to really almost always give you a good answers that people like. And that's when this becomes like a human, like that's when ChatGPT took off and people think, oh, this thing is really amazing and it's like me and it thinks like me. That's where it came from. And OpenAI being the first to the scene, they had all these users with all these data, so they really surpass everybody, and they took off from there. I don't want to cover a lot because I don't want to spend a lot of time with you guys on that, but I want to cover the questions I have the questions that we have here a little bit. So, and then you guys welcome to ask me as we kind of go through things, but I want to make it more interactive rather than me talking to you guys all the time. But I want to say the first question I have is everyone is talking about ChatGPT. Where does ChatGPT sits in the landscape? And that's the answer. Right now, ChatGPT is on the top of that. So the best models is OpenAI's. Obviously, they just came out with the latest, which is I think Omni, it's called, and they just came out with another one called Mini Omni just a couple weeks ago that replaced ChatGPT 3.5. So no more 3.5 anymore. It's a lot better and cheaper even. But anyway. So in terms of performance, and I work with these models day in and out, so that's where my expertise is. I forgot to cover what I worked on, but I started in Vision AI. That's where I started. That's how I know landing AI and other things. But I started my career working on Vision AI and understanding, computer visions and other things among, cameras and other things within appliances and things like that. Then I moved away from that to what we call edge AI, essentially living on the unit, looking at sensors and thinking about what I need to do and looking at AI doing better than traditional mathematics. Then I moved away from that and I'm focused on generative AI right now, and that's where I spend most of my time lately is generative AI. And how can we create value using these tools, as unpredictable they are, because they're not there to serve you, they're not there to follow traditional goals that you have in mind. The question is, how do you put them as a components in your system and make it more predictable to really do the job you're trying to do more efficiently and gain more. That's where I spend a lot of my time in that field. So in terms of who's the best to who's the least best, right now OpenAI is sitting on top with a close seconds being, Claude or Anthropic is the company, essentially. And these guys made leaps, even though they spend a lot more time on the data. They pride themselves on, they kind of started with the good, clean data and cleaned up the toxic more than anybody. So they, and they partner, and you'll see them a lot more coming through to your homes if you have Amazon, any of those Amazon speakers or whatever, Echoes or whatever. So they will be employing those models on these units. Essentially, those things is going to become more of a companion. They'll be chatting with you about your day, whatever you do. So they're using that. So they partner with Anthropic. So they came out with Sonnet, I think the last model or whatever. It's amazing. It's amazing. I've been playing with it. It's really good on coding if you're interested in something that helps you in coding. Or I was able to, it's gonna change the life of coding and the coders. I was able to create a game in like 5 prompts. Like it was working and I was playing it in the browser, like Tetris. I created Tetris in like 5 prompts. Like it was there. I'll show you guys a little bit. But so and then below those guys is Google, believe it or not. And then below that is everybody else, essentially Meta, Llama models, and these other guys. The other question I have here is, how can I best take advantage of ChatGPT to improve myself and my workflow? And this is what comes back of your expertise in the fields and taking interest in the knowledge and understanding how these things work and what they do. At the end of the day, they're predicting the next word. They're trying to predict that next word. Is how do you give them the best chance, if you will, to do that job for you? So I think this is going to vary about what are you doing. If you're a coder, Sonnet is going to be an amazing partner to help you code and get up and running in no time. Any of them, as a matter of fact, do a really good job, but Sonic seems to be focused on, they showed a lot of coding data, seems to be like really doing really well there. But also, any of those models can help you there, but any other tasks, depending on what you do, if you're doing innovation, and part of, my team is part of innovation and other things, like we used traditionally to sit in a room with like 20 different engineers and brainstorm about a problem. No more. You can come to that room with ton of knowledge if you did your homework on ChatGPT and gave it a scenario of what are you trying to solve. And then instead of you spending hours and hours in meetings, maybe you spend 15 minutes and get better results because you're coming in with their own ideas based on how they started on the prompting side. And maybe we'll pick something winner in no time and then have a products and solve a problem really quicker. So it depends. It varies on what field you're in. It'd be different ways to use that model, if you will.
Khalid, if you don't mind, I have a suggestion, because most of the people that sent in those questions are here.
Yeah.
So a lot of those questions were before your very informative, lecture. Maybe some of them are not applicable. So I would just say, instead of going through the questions,
Sure.
people are here. Raise your hand if you have a question. If you sent in a question that wasn't answered by the presentation, just raise your hand, and I would just add, introduce yourself. Hi, my name is Muhammad Ali. If you're in high school, college, you're a little bit of background, so he can maybe tailor the answer to that. So just feel free to raise your hand, and at the end we can.
Yeah. That'd be good. Yeah. If not, I'll pull out of here.
Okay, my name is Ahmad. So I'm doing research at the university. Right now, my interest is basically the use of AI in medicine.
Mm-hmm.
I just had a couple of things to confirm before I ask my question. So you said the AI is called Sonic or Sonnet?
Sonnet.
With a T.
Like a
Sonnet.
song, sonnet.
Like a song sonnet.
S-O-N-I-T.
E-T.
E-T, okay.
SONNET, sonnet.
Is it double N?
Yeah.
Double N.
Let's see. Yeah, it's
Yes.
yeah, it's SONNET.
Okay. So another thing information to confirm would be in reinforcement learning, is the agent a human or is the agent the model itself?
The agent is basically you program it. It's kind of like a character in a game, right? You give it a goal and a task and whatever, and then it's just gonna go and exploit that whatever you're trying to do. In this case, it can be a model, it can be whatever, right? Essentially, what your goal is, depending on what your project you're working on, what's your goal? And let's talk about ChatGPT in light of that. What does that look like? Essentially, we talked about the reward function, so now we have a way to know what's good and what's bad. The actual agent in that case is the last stage when we let it chat with itself. So that thing that facilitate the whole thing of chatting with itself and what it should do about fine-tuning the model or changing the model, that's called an agent. It's just a word used. You'll hear it used in different ways. Essentially, think of it as assistants or agents with a single task or a goal. Anytime you have something with a goal, we call it an agent. So it could be anything, as a matter of fact. It's just a way to use it. That something is exploiting your environments or and then trying different things on it, and then learning, and then updating itself and trying again. So that's just a basic code, whatever that is.
So when you say it's exploring the environment, is it, let me just give a very simple example. Is it like, for example, if a little kid will get you, I don't know, a banana, and then he will come to you and tell you, is this a car? And then you being the agent, you would tell him no. And then the kid will just go back to the environment, and then play with it again, and then bring you, I don't know, an orange, and then is this a car? You
Yes.
no. Until eventually he gets it right, and then you
Yes.
yes.
Yes, essentially, agent is responsible on trying to accomplish a goal and then failing a lot along the way and learning from their failures, and then hopefully employing that learning to get better and better and better, and impacting that environments and changing the models in the process. In this case, in case of ChatGPT, the brain of that agent is the model. So the model is changing, thinking how toxic that thing is, how much on the reward score that the answer is, If it's bottom, then I failed. Then I need to do something different. Then they do something different, and then it kind of like with time, they start actually making the model better as they're trying to get to their goal of getting the maximum score, if you will. Like if you're playing with your son to go get money for every time they get something good, and then kind of doing it that way, and then they eventually now they realize that I'm gonna get a lot of chocolate if I do it right. Then yes, that's the agent cycle right there, right? Makes sense? I don't know if I'm explaining it right, but
So I'll rephrase my question. So let's say, for example, the example of semi-supervised learning. The whole process is basically like me, the human, I'm the person who is developing this whole system, right? Then the machine is the little kid that's learning.
Mhm.
And then at first it did the clustering, and then I kind of taught it, okay, here's the label, here's the label, here's the label.
Mhm.
Then that fed back, and
Mhm.
clustered again. Then here's the label, here's how good you did. What is the difference between that process that I just described, which is the continuous feedback from me, the
Yes.
human who's teaching the
Yes.
supervised machine, versus reinforcement learning? Can
Yes.
you just automate that whole process that you mentioned?
yes, what you did there, what we call a human in the loop. So you're in the loop. You're kind of thinking about this and helping it along the way. That's also a way to do agent, because you can have a human in the loop or no human in the loop. And the way we created a reward function so we can take the human out of the loop, and then we just capture the human preferences based on that initial data, that thumbs up, thumbs down. Remember? So now you're not needed in that loop, so I can go faster. You know what I'm saying? But yes, you can do a human in the loop. As a matter of fact, that's the stage one when we created that reward function. And from that reward functions, when we let it go, now you're out of the loop. Now we let it just go optimize itself to accomplish what you fed it as a goal, the so-called reward.
Okay. One last thing. Why was knowledge retention and discovery? You said that one of the big discovery things in ChatGPT is that they discovered that it retained knowledge.
Mhm.
Wasn't that kind of an expected goal already while you were building the model?
No, it was more like we want this model to learn how to write in English. They didn't know that it's gonna understand that the capital of France is Paris, or whatever that piece is, or whatever question you ask it, it's gonna be. So it was initially the goal of those guys were, I wanted to understand the grammar and the structure of writing English language. That's it. But then as they fed in more data and they grew it, they noticed that not only they understood the structure and how to write data, because that's the completion model, right? They found out if they tease it, they say, give a couple examples, it will start answering questions, even questions that wasn't even trained on. They will infer the questions out of it, which is amazing. They're still kind of researching and seeing how's that memory working and how good. So there's a lot of research in that area to see, like, you know, how these models are behaving and why they're behaving that way and how they got to do better or worse on certain things. So yeah. Oh yeah. Any other questions? At what time we got? Hold on. Just time check.
Take more.
Okay.
We're wrapping up with questions, so
Yeah.
One question I had
and you're
was,
next.
how can we use?
name
I will know.
I know him. Mahad Mohammed, part of the Muhsineen group. What? So I was thinking of how can we use this AI in the Deen, for example.
Yes.
You know, one thing is there's a lot of literature or Islamic literature in Arabic. Is it a good idea to use AI to translate into English? I know English words are limited.
Good question. Unfortunately, in terms of Arabic language models, there's very limited. I have a friend, I think we went to school together. He's a professor in somewhere in Saudi Arabia, somewhere leading the AI center there. They focus the research on making models that is Arabic friendly. These guys is not interested, right? They're focused on whatever they want to accomplish in these models, and specifically around English. As a matter of fact, I work with other people within our company is global, so we have people in different ways and they have the same problems. Even other languages we tested, we found out that is not as good. Forget Arabic. Arabic is one of those ones that they actually not really good. We know that ChatGPT is not good at it, nor Google, none of those guys. I haven't tested Anthropic heavily, but mostly they don't do good because the initial data they trained on is not there. So I know there's a lot of research in the Arab countries, or universities, and especially in Saudi Arabia and these universities that focus on AIs. They're trying to position themselves like the center of AI right now. All these, if you will, Dubai and all these guys, the Gulf countries, if you will, they're pouring a lot of money in this field, and a lot of their focus is that. So if you're interested in model that is do good on Arabic language, I would check. I don't know if you're familiar with Hugging Face. Hugging Face is a place where everybody have a model, trained a model, whatever. They want to put it out there for people. It's like a place you can find it. They have many Arabic ones, but I would read a little bit to see how good they do and test them. But I can tell you they're not performing as well as English ones so far that I ever looked at it. But it's getting better. Before coming here just this morning, I read that they just launched another Arabic one that is focused and whatever. But there's a lot of research in that area to make it better. But eventually, yes, you can do, if we cross that path, which I think it's going to be very soon, because there's a lot of money poured in that field, and they're hiring all kind of people to train models on Arabic language. We would see a lot of things, where you can chat with it in Arabic language, get Arabic back, and even it will retain Sirah books and everything else. Yeah. The question is the big thing to keep in the game is keep your mind in the game, because these models can hallucinate. I can't say it right. Hallucinate. Hallucination is essentially when there's a gap in the data. It's a black box. We don't know what that model's seen and what that model didn't see. So if you ask it an obscure question and it didn't have an answer for it, it's helpful enough to start making up stuff. And essentially it never says, I don't know or whatever. It's not trained. But that's a dangerous part that comes with this. So I guess as we get more into religion and having these models out there, probably that's going to start showing up. Is this thing is giving completely wrong answer? Why? And how can we accommodate that? But hallucination, there's a lot of research across the world kind of going into minimizing that, because that's one of the biggest, if you will, gaps in this generative AI, if you will. So they might make up some model, and us users, we don't know what that data look like. So I don't know where the strength of that model is and where the weakness is. So that's when there's many different tricks for another session we talk about to ground the models and make them better in your area that you care for. So if I'm doing something about Islam and Sirah, I probably want to introduce the book again just to make sure I ground the model with that data. But first, I got to get a model that is good about Arabic and understanding Arabic to begin with. So it's answering more naturally of a native speaker. But we're not the only language, so it's not anything to do with bias. Other languages are really bad, especially the Eastern Europeans languages. They're not very well represented in those models. So a lot of those countries taking leaderships and making their own things and kind of strengthening that gap on their own models, or fine-tuning those models to become better with their data.
We'll take one final question if anyone has a short and quick question.
Yeah, he had his hand up, we'll take two. We'll take two.
Alright,
So
let's
he had his hand up, and then.
Mine's just very quick. Assalamu alaikum. My name is Ronnie Cater. I'm a barber here in Louisville. I just had a quick question about the reward system. So, like, why does the AI find incentive in the tokens? Like, what does the AI gain out of it that it finds that incentive? Do we know that?
It's not the AI. It's essentially a trick we play. The goal was for this so-called reward is they had a model that it can answer questions, right? But the answer were not really like, if I ask it a question and I'm a human being, I expect a certain way that question is being answered to me. That wasn't there in the initial so-called fine-tuned model, like stage 2, when I showed you on that little page or whatever. That stage 2 here, that wasn't human friendly. It was like, you can tell it's a machine-like, it's like tucked together in a way. Maybe the knowledge is there that you need, but it's not really friendly, like to read or understand or like feel like you're talking to a human being. So that's when they research how can I make it, and obviously the reinforcement learning was on the scene, and so they said, okay, maybe we just design a way to tell the model when it's doing a good job and answering something I like, and telling it a bad job, or I give it -1 when it's not, or something, right? So that's the whole reward incentives piece that they designed. And then now when you model so-called the rewards of human preferences, now that so-called reward function becomes your judge as the model chat with itself. You see what I'm saying?
Yeah.
And now you're taking your model to become closer and closer to how we like things. And obviously what I don't cover in this more is they do have more things to guard against bad stuff, and that's a question that is actually, so there's many things they put where they would pass this to another model that will judge how toxic this thing is. So there's other models that you don't see in the backgrounds. As soon as you ask a question, it goes through some other filters and models. That's why when you ask it, how do I make whatever, you know, illegal, how do I break into a car or whatever, it won't give you that answer right out of the back. There's ways to hack it, but out of the so there's a whole big community. It's like a mouse and a cat game, because they would put guards and there's people that find ways to get around it. And it's kind of like a continuous game of figuring out how do I guard it enough and make it still useful versus guard it locked from being useful. So, but that's really the whole incentives of the whole thing of the reward piece. And I think you had a question. Muhammad, it's fine if you want to go on. If we want to go a little bit longer, I'm fine too. Whatever it takes to answer questions.
Well, we'll say for now last question.
Well, Khalid, my question about the machine learning. So you mentioned like about the amount of the data that you give it. So it's like deep learning and learn by itself, so it can make decisions. What about this data is like unlimited, and it like varies like every day? For example, can we use like a machine learning, for example, in the stock market?
Good question. It's actually, this is one of the blind spots of models, because they freeze their knowledge to whatever the last training is right now, right? So essentially, so whenever the date, they lastly showed the model some data and let it train, that's the data, the knowledge they know. So if you're thinking stock market, it's changing every second, right? So how would I take that thing into account? So now newer models allowed their model to go browse the internet. So like ChatGPT now, if you chat with it and it doesn't have the answer, they do something called function calling. They would call a browser on the back end and search it like you're searching at Google and grab that stock price and bring it back to you. So instead of keep training the model with new data that never ever ends because it's changing, so they would give it access to go get the data and come back and then make it, and maybe it comes back with the data, why Apple is struggling or the stock of Microsoft went down, like after their issue, whatever. Then it comes back and say, here's what happened to them and that's why. Because it goes search the internet, it pulls that data in, and it will just, if you tell it in the prompts, tell me like I'm a 10-year-old, explain to me why Microsoft stock is down, that's when it adds value. It just goes get that complicated data, and it will really explain it to you as a 10-year-old, whatever you want to tell it, and explain it why it really did what it did. So it's still using the model knowledge, language model, about how language is synthesized and how can I explain something to a 5-year-old versus 10 versus 20, whatever. And it's still just accessing live data. This is a whole different session we can talk about. It's called RAG, the whole situation. Essentially, where you allow your model to go get data that you care for. Could be stock data, it could be documents, could be Sira books, it could be anything. It'll bring that data and it will try to explain it back to you in a good language. So if you try to understand the hadith in the future, it will bring the hadith and it will try to explain it to you the simplest way it can do, like change those fancy Arabic words into some normal words that you probably can get. So that's in the future, but it would be possible to learn that way.
For example, we were working on some model like this, and it gives, for example, the data or the stock market through last, for example, 4 years.
Yes.
And it will study every single stock.
Yes.
What all the stages that went through.
Yes.
So it can give you a model, like it would be like, okay, which stocks I'm gonna buy, for example, tomorrow.
It will. I mean, obviously, part of the guarding, they probably block it from giving you any stock advices and things like that, because they don't want to take responsibility. You lost a lot of money because of ChatGPT. So, but yes, technically, it will be able to look at the history of that company. As a matter of fact,
Can you
sentiments.
pick one, like-
Yeah, sentiments. We call it sentiment analysis, and they do a lot of that recently. Essentially, you look at one of the best used ways. Like if you're trying to invest in Microsoft and you just say, here's the last call of the investors. Tell me what's good and what's bad, and should I go or not go? It will do really good. It will analyze the whole thing without you reading a word, and it will come back and say, I like this, here's the positive, here's the summary, here's the negative. So that's a good way you use it if you're investors, right? But essentially, you always got to keep in the back of your mind, this might have made something up too. So I would want to ground myself. If I'm really putting a lot of money, I would want to look at that data and make sure it's not making anything up, right? But technically, yes, they're getting a lot better. You feed it 100-page or whatever of the company, whatever, and it will just come back and give you recommendations on or summarize what's the status of that company, is good or bad, whatever, to go invest in it. Yeah.
So thank you so much, Khalid, for coming and spending your Sunday with us. Inshallah, we foresee this is not the first and last session. So I would, tell all of you, digest them. We could probably get this presentation. You can share that with us.
Yeah.
Digest all the information that you heard here. In the next coming weeks, think about what would you like if you had further sessions, right? If you're interested to really have like a boot camp style. I know Omar, was very interested. It's like, I want to learn. I want to do this. We've got Khalid. One interesting thing that he said. Yeah, I'm going to touch on that. One interesting thing that he said is you don't have to go and build your own models like that. That's not the job of everyone. We do have someone who actually does that as his career. We have Abdul Hamid here, who works for an AI startup for one of the CEOs, one of the top AI folks in there, and he does actually build models and everything, that all the complicated stuff that we talked about here, which is like the background, he actually works on that on a day-to-day. But keeping that in mind, with Khalid and with Abdul Hamid, we can take this in whatever direction that you guys would like, right? So keep that in mind. We're not having a session next week or in a couple of weeks, but we'll give you time, inshallah. We try to have a diverse, different, every month diverse workshops.
One thing I was gonna say, remember what I said about the next innovations are coming from people with expertise, taking interest in AI. So you don't have to build your own models. The question is, how can you use these tools that are already available to really solve a problem that everybody cares? And I want to leave them with one example, just to show you a good example. I was in CES, or Consumer Electronics Show, early this year, looking at, that's where all the companies get together and show their latest and greatest. And obviously AI was like, everybody's doing AI, right? One of the things that really captured my eye is essentially kind of hone in that point and kind of make it clear, is this guy in a company that took interest. He's a psychologist. You would think, okay, who's psychology? Well, what is AI? It has to do with psychology, and why would I care, right? But this guy took interest in AI. It could be just starting like this. This is interesting. I want to learn a little bit more, and kind of grew that. But essentially, he took a model that we use every day. If you have an iPhone or whatever phone, now you do face, you unlock your phone using your face, right? Exactly. So in the back ends, there is a mesh thing that overlays over your face, and to make a long story short, it will just look at your distance between your features, and everybody's subhanAllah is unique on where their eyes and everything else located, and their nose. So just doing math on those points make the model know it's you versus somebody else trying to unlock your phone, right? But this guy said, okay, I know this model exists. It runs on your model. It's, by the way, that model runs without internet. You all know that. You can turn your internet off and still unlock your phone, right? So it's living on your thing. So it's a small model. It's nothing. It just works really well. So this guy took interest in it and said, I probably can understand, people emotions just based on distance between that. So when you smile, or you're happy or you're sad or you're depressed, these points on your face is gonna have certain patterns, or it's gonna change, right, as I'm talking to you. So subhanAllah, then he designed this model that has a whole circle, and I tried it, it works really well. And as you're talking, you will understand where you're emotionally. It'll plot where you are emotionally, like live. You'll be like, I'm happy, he's sad. So imagine this, and what he's doing with it. Essentially, this is out of COVID time, right? This is the first CS after COVID, like in person. So essentially, the idea is with the rise of depression and everything else, and all these issues, he was thinking, how can I solve for having a quality session with somebody in their home without them seeing their face and being there with them? So essentially now you can turn a camera while he's interviewing, or she, and then they would, as they're asking you questions that they studied, they would know where emotionally you are, and they'll be able to pinpoint exactly what your problem without being with you and knowing you. Not only for people that is from home, but it's amazing change to children that can't even express what their feeling is. So if they're going through traumatic things like the kids out of Gaza right now and things, imagine those kids trying to explain to you what they've been through and what they're feeling. But they can drill down by just looking at their face with a camera to what exactly happened to that kid and where they are and what kind of treatments they would do to them. Amazing. I mean, this is somebody just took an interest, and that could be anybody of you guys that really just say, okay, I want to do this, and I want to see what other things I can use this. So it's not the next model, it's not the next chat, as exciting as it is to train a model and everything else.
That value.
It's that value, and where it meets the needs, where it becomes amazing and change the world. So now you can diagnose with confidence these diseases that wasn't available before.
Yeah, that's a really good, anecdote to kind of end on. If there's anything that you take out of this, it's you use AI, ChatGPT, generative AI in whatever field that you are in or want to be in. So that's kind of how you think about it. If you're in school studying, think along the lines, where am I going, where am I headed, and how can I utilize this in the field that I'm an expert, right? So that's an amazing example for a psychologist to come up with an AI model, because he understood the importance of it. It's a tool that you can use. You don't have to be an expert in the tool. You are already an expert in your field. You're using this tool to help you come up with something that adds value.
One last thing, and I know I'm probably taking more time, but it's important I want to address, because I had a question here that people ask is, how do I protect my family from all these scams? This is very important. We got to communicate. How do I, who asked that question?
I think it was,
here you go. This is very important. How do I protect? I mean, there's a lot of scams happening. There's many ways that when you have tools, they can use for good and bad, as anything, as any technology that shows up in the scenes. Internet has been used for good and bad, right? You guys all know. But essentially, how do I protect my family from all these things? So this is very important. And right now, there's a lack of regulation in this field. So it's a wild west. So essentially, as the internet started, there's probably wild west there, right? Initially, we're living in that moment for AI, essentially. So how do we protect ourselves, and our family from those things? One of the biggest things is you get a call, somebody in distress, and they ask you for ransom. That's very common right now, because they can make your voice up, they can make your image, you can make a video, you can everything. They even can write you a convincing email in non-broken English, because all days you're looking at broken English in an email. Okay, this is somebody's trying to scam you, right? They got good English now. ChatGPT is writing the emails, right? So essentially, the best advice to you is have a plan with your family. Like, have some words. Like, if somebody called you up, how do I recognize that's my wife? You have to agree on a certain way, on a question you ask, and they only can answer. And it could be to anybody is nonsense, but to you guys is a code that's me. So this is where we are right now. You have to have a plan where you ask a question in a certain way and you expect a certain answer. And if they say it slightly different, you know it's a scam. And every time you get a call, hang up and call back by their number. Because they can call you with their number, with their voice, with their image. That's all checks right now with AI. So essentially, your only guarantee, and my favorite is, I was reading an article from this AI guy, and he said, I password protected my grandma. Essentially, I taught her certain things that we would ask each other and answer in a certain way, and that's how I protect. So if they called me that they took my grandma out and they want $1 million, I would ask something, and then that something is, if it's not checked out, we're, you know, I
Security
already know.
question.
Yeah,
about.
basically, yeah. For
Yeah,
your own
so
family members.
I just wanted to share that with you because it's important. It's wild, wild west. It's pretty messy, and we don't know what to expect next.
That's some good
that's it.
practical advice.
Jazakumullah khair.
Thank you
and
very
thanks
much.
for-
Thank you.
Khalid, before you head out, we haven't concluded the session yet. For the Mexican, a couple reminders, of course.